There's tons of important technologies or things that have been conceived that sit in scientific papers. We have an abundance of great results, but the bottleneck is in between science and technology building. That's the key part. And it's scaling that is going to let us cure more diseases faster, and so on. Now, Bell Labs is a huge inspiration to a lot of us in our network. It was an amazing hive of invention. It was responsible for so many of the technologies that we now take for granted. And they understood the translation process extremely well. The way they modeled it was as a full R&D pipeline, starting with research with small groups, but where the bulk of the work happened was afterwards, in what they called fundamental development, productionization, production, application development, and then later on, operating the business. Although most of the academic credit happened on the important discoveries like the laser and the transistor and the solar cells and so on, and usually most of the attention went to the few people that kind of had that conceptual breakthrough, the vast majority of Bell Labs' work sat downstream of that moment. They understood that innovation actually happened later. They described innovation as actually getting a conceptual result into being developed into proofs of concept, into devices, being put into a product that was delivered to the market. And they said that if you hadn't sold something at massive scale, you had not yet innovated. One other important piece here is that it is not a linear thing where one project turns into scale. In reality, one single idea will yield many possible paths, many different projects, many approaches, and of those, only one of them often will end up working out. From there, you try to productionize in a variety of ways, and only one of those will tend to work, or a few. And then once you have many attempts, there will usually be something like 5 to 20 startups working around the same idea, and eventually 1 or 2 will win. So this is a pretty large pipeline that involves tens to hundreds of teams working on the same idea across a 10 to 15-year time span. So when you think about large-scale R&D, what the world will benefit from is a large open network that enables as many groups as possible to give it a shot. What we benefit from is going from ideas to production as fast as we can. And the current IP structures, the current ways in which groups and companies tend to operate, they tend to try and hold back other groups from trying the same thing. And that's a mistake. What we want as a group is we all benefit, game theoretically, from speeding up the pipeline. So we should be thinking about new structures and new ways of accelerating this. New forms of IP that are more open source amenable. New funding structures that can come into the pipeline here.